Performance is why people use C++, but with great power comes buffer overflows, memory leaks, and use after free. So I decided to throw every memory linter I could at my holder-daemon card server and see what they found. First, I ran AddressSanitizer, memory error detector for C. It finds use after free, heap buffer overflow, stack buffer overflow, global buffer overflow, and use after return, use after scope, memory leaks. So I ran that. It found 4 little things. None of them were kind of exciting issues where holder will steadily consume more memory during normal use and explode. None of them were like that. It was just lifetime correction, similar to before, how the program gets out. Another thing is that holder has a reindex command. Doesn't get run very often. The app stores cards and AI messages and stuff in SQLite. So source of truth is the cards, the files on the disk, but it indexes them in SQLite. Reindexing is the maintenance job that says empty the search tables, read every card and every message, like AI message from the database, and put fresh rows back into the full text index. This was not anything to do with the happy path. So on the happy path, it prepares an SQL statement, loops through the rows, and calls SQLite 3 finalize at the end. This function calls this at the end. So the kind of edge case was that when SQL3 is writing, if it threw an exception, for example, your disk is full, or your disk has been disconnected, or your disk is somehow changed permission, or something weird like that, then we jumped out of the function in not very memory cleaning up way. So in Python terms, it's like open a file and then close it at the bottom of the function. If anything raises for the bottom, the cleanup doesn't happen. So you use a with statement. You open with, and then whatever happens in the body of the function, you clean up at the end. And this is kind of the same thing. RAII, resource acquisition is initialization, is a core programming idea primarily used in C++ and that other language we don't mention, that binds to the lifecycle of resource like heap memory, file handles, network sockets, the lifetime of an object. Resources are acquired in a constructor and automatically released into structure when the problem goes out of scope. So that's what we're doing here in the reindexer. So I made an object called statement deleter. So we put the resource inside an object whose constructor does the cleanup. So this little statement deleter thing is the cleanup rule for this SQLite statement. So exciting times. What else? The order of the handles that get destroyed. So Boost has this IO context. So this handle has a reference to the IO context, and we have to make sure we get rid of the handle before we get rid of the IO context. Otherwise, this can access something that doesn't exist anymore. If the handle has a pointer to the IO context, and then we delete the IO context before the handle, then the handle can point to something that's already been deleted. So again, just tidy up problems, ordering of the tidy up. And then we have the bit that actually runs. So if I run this, make.shut, and then san, it runs this san all, and then san all is up here. And then it runs all of this. So I don't have to remember all this stuff. I can just do san, and it will run all this stuff. It's very exciting. So yeah, compiles, it's completely tested, and it's done clang tidy. There wasn't that much left for this to do. So I'm going to click all these. Right. So that was exciting. It was interesting. It was very interesting. Well, less work than I thought we would need. And people say, oh, it's all trouble, you know. Memory is so complicated, we need to use that other language that manages the memory for you. Well, you're on the Linux, it's fine. Okay, next I ran UBSan, UndefinedBehaviourSanitizer, and it looks for these things, and I didn't find anything. Next I ran the ThreadSanitizer, which is a data race detector for C++. So basically dealing with threads playing nicely with each other. I ran it. It did come up with a few things this time. It was again all to do with shutdown. So I made a script to run TSan. So if I do make.san thread, we then build it with TSan and does all the things required to run it. External dependencies made a lot of noise. I'm not really testing libsecret or gdbus, so don't care. So I made it skip all that. And then the actual changes. So again, shutdown, clothes, destructor. It's all kind of similar theme. It's not really to do with the runtime code. It's all to do with bringing the system down. cleanliness, professionalism thing. The system comes down either way. Nice to be all clean and thread safe, but the thread issues were all to do with bringing it down. So that's all we found so far. Okay, next I added Valgrind, which is the entrance to Valhalla, but also a memcheck tool. So we added the configuration for Valgrind. So if I do make dosh memcheck, it runs Valgrind memcheck, and it takes 64 minutes and it finds nothing. It's not going to be good in a pipeline, but worth occasionally checking. So what we've done so far, so we've got Clang tidy for static analysis and maintainability warnings, Clang format for format inconsistency, compiler warnings with W error, ASan and LSan for memory safety and leaks, UBSan for undefined behavior, TSan for data races, Valgrind memcheck is a second memory checking path, and coverage to find untested lines. So there are the linters that I've made so far for the back end. I think that's pretty good. So in terms of code quality and memory, we're pretty sorted. There are the linters for security. I think I'll do that as another weekend. So it's some of the security tools tend to be, you have to pay for them, but if you're an open source project, you get them free. So I think I have to open source this to get CodeQL or whatever it's called. GitHub CodeQL, code bases that release under an OSI approved license, which we've done. So I mean, it's a local thing that runs on your system, so everything can get out anyway. But once we've open sourced it, we can run this CodeQL for free. Yeah, I think I'm getting pretty much there. All the linters have paid a lot of interest into my shutdown path rather than the running path. Somehow that was all right. It was mostly the shutdown they were all focused on, and because you're shutting down anyway, if it's slightly memory inefficient a second before it closes and uses no memory, it's slightly pointless, but we have tidied that up. So now we are completely covered. So even while shutting down, we're going to be very memory efficient and thread safe and everything. So yeah. If you think I'm missing something, let me know. What modern tools should I be running on this C++ code base? And yeah, I'll keep you updated on this project as I move forward. It's getting pretty quality now, to be honest. For what it is, 20,000 lines, which isn't the biggest code base in the world. It isn't small, but it isn't tiny, but it isn't that like massive code base, but hopefully maintainable as a project. Right, so thanks for watching. Leave a comment, say hi. I read every single comment, so subscribe and have a nice day. You go code something.